welcome to the Mathematicians Podcast, the podcast where we follow the fascinating stories behind the people that count in the history of mathematics. I'm your host, Benjamin Cornish, and today we are studying the writings of one of the oldest study guide writers, the guy behind all of human knowledge. I used to have a friend who was an infrastructure blogger. In particular, he wrote about the very fabric of his adopted home city, Rome. Every day he would go out for a walk around the city of Rome and notice interesting things. He would then go home and research how these things came to be, and he would then write this up on his blog and share with the world curious nuances about the city. Now you might be thinking that this would make for a very interesting blog. Rome, after all, is nearly as old as Paris, and there must be many an interesting story to tell. However, my friend would focus predominantly on the newer additions to the city, from about the 1870s onwards. Railway links, street lighting, sewerage, etc. Like I say, fascinating stuff. Over the last few years, I haven't heard much from this friend. After all, blog writing really takes up a lot of one's time. But it has been a delight to follow his journey on his website, and to know that although we are no longer geographically close, we can share a mild amusement over the latest westbound extension to a certain metro line. Sadly, he has not updated his blog, and I'm sure there has been a whole wealth of history from the last 150 years of Rome, or, as he would put it, the interesting part, that I am missing. What is more, he has not responded to my last 4 months of correspondence. This story, granted, does not have wide appeal, nor does it particularly relate to the history of maths. But if a man can't start up a prize-winning podcast and wait 30 episodes for it to gain widespread appeal, just in the hope that he can tell a friend to pick up the damn phone, then what can he do? Today's subject is Theon of Smyrna, born around 70 CE, give or take a haircut, in what is now Izmir in Turkey. I'm not overly excited to talk about him, because he didn't radically change the game in any way that a lot of the greats did. What he did do was write a long, slightly exhausting, but surprisingly useful book called Expositio Rerum Mathematicarum ad Legendum Platonium Utilium, which translates loosely to Mathematical Matters Useful for Reading Plato. I doubt he wrote it in Latin, though. Even as he was born a citizen of Rome within the empire, he would have written in ancient Greek, given that that was the predominant language of the academics. In particular, he was of the block capitals no spaces school of writing, much like right-wing politicians today. The copy of his works we have are Arabic translations. Once again, our thanks go out to the Islamic Golden Age. In fact, today's episode is sponsored by the Islamic Golden Age. Sign up now for 30% more age with every purchase. Theon wasn't so much a trailblazer as a tour guide. His work is like those Plato for Dummies books you can get when trying to figure out the form of the good. He's giving you a cheat sheet for understanding other people's brilliance, namely Plato's, but also Pythagoras, Nicomachus, Euclid, and the whole gang of long-bearded, toga-wearing brainiacs. If he were alive today, he might have started a blog series about the construction of Rome. Oh, hey look, I shoehorned it in. Today, we're going to explore his life, what little we know of it, his philosophical ambitions, and of course his mathematical writing. Because while Theon wasn't inventing the wheel, he was cataloguing its properties with impressive rigour. Let's just say he put the thematic in mathematics. First, the basics. Theon of Smyrna was a Middle Platonist, which is like being a Neo-Platonist with training wheels. The Middle Platonists came after Plato himself, but before Plotinus made it all mystical. Their job? Interpret Plato without turning him into a theological fever dream. Theon's name crops up in a few ancient sources. He's mentioned by Proclus, Ptolemy, and other commentators. He had one surviving work, that massive Mathematical Matters guide, written in 2 parts. The first half is about arithmetic and music theory, because, of course, they go together, and the second, less intact part, deals with astronomy and optics, though only the introduction survives. This dual focus, maths and music, cosmos and calculation, ties back to the Pythagorean dream that the universe is structured by number and that everything hums with maths if you listen hard enough. Either that or the ancient world really couldn't decide between calculators and harps. Theon's main contribution is his effort to help students read Plato with the right background, because, as everyone who's tried to read Timaeus knows, Plato is not exactly user-friendly. You're trying to understand his cosmology, and suddenly you're drowning in triangles, intervals, and talk about the world soul like it's a character in Tolkien. So Theon wrote a book to say, hey, here's the maths you need, so Plato doesn't melt your brain. He wanted readers to see Plato's dialogues not just as metaphors, but as carefully calibrated numerical allegories. And here's where things get peculiarer. Theon's maths isn't just about solving equations, it's about categorizing numbers, like you're curating a very nerdy museum exhibit. Some numbers were noble, or mean, or harmonic. They had relationships, personalities, even family drama. Welcome to the world of Arithmetic, where numbers are not just quantities, but qualities. So let's talk numbers. Theon's Arithmetic draws heavily from Nicomachus of Gersa. Remember him last week? Theon explains in painstaking detail the kinds of numbers the Pythagoreans were obsessed with. Even and odd numbers, perfect numbers, deficient and abundant numbers, figurate numbers, those are the ones that are triangles, squares, pentagons, but as arithmetic objects, not shapes. So, like the triangular numbers are 1, 3, 6, 10, formed by stacking dots into triangles. He also gets into ratios, big time. Theon distinguishes between types of proportion. So we have arithmetical, A plus D, A plus 2D, geometrical, AR squared, but also harmonic, where the reciprocal of the mean is the arithmetic mean of the reciprocals. And yes, that sounds like a riddle, because it sort of is. This attention to ratios wasn't just for fun. It was tied to music theory, philosophy, and Plato's cosmology. For the ancients, a musical interval wasn't just a sound, it was a ratio manifesting in time. Theon shows how these proportions give structure to both music and the cosmos. He's basically writing the user manual for the harmony of the spheres. Now let's talk about the monochord, a one-stringed instrument used for measuring musical intervals. Theon loves this thing. He explains how dividing a single string by different ratios yields different musical tones. And this isn't just a party trick for ancient bards, it's a tool for showing that sound obeys mathematical law. A 1 to 2 division of the string gives the octave. A 3 to 2 gives the fifth. A 4 to 3 gives the fourth. Who knew plucking a string could sound like a theorem? The monochord, in Theon's hand, becomes more than an instrument. It's a bridge between physical and abstract, between the world we hear and the world we calculate. You could say he's stringing together metaphysics and maths. This idea, that music, maths, and the cosmos are all intimately connected, is what made Theon's work so important for philosophers trying to understand Plato. Plato didn't just toss maths into his dialogues because he was bored, he saw it as a pathway to truth. Theon's treatise helps map that pathway. It is curious here to think about why the ancients were so obsessed with music, though. Many modern mathematicians would not recognise this as a valid form of study. Here I might reference that learning mathematics is inherently a social construct. The way our brains form patterns and make connections is inextricably linked to our culture and society. Even to this day, many cultures explore group theory with their children before counting numbers, or perhaps order values based on prime relations rather than absolute magnitudes. Nothing really makes sense any more than anything else, given that all of maths is abstract. So yeah, the ancients thought largely in ratios, harmonies, and music. It just made sense to them. The surviving portion of Theon's second book, on astronomy and optics, is brief. Only the intro remains, which is unfortunate, because this part likely discussed how geometric ideas underpinned the movement of celestial bodies. We can't say for sure what Theon wrote, but given his style, it was probably equal parts technical and philosophical. He likely viewed the heavens as a geometrical dance, not just a mess of orbs flying around the cosmos like marbles, but a highly ordered, structured, following number and harmony. What we do know is that Theon emphasised the need for mathematical training before entering these fields. He writes that astronomy without arithmetic is like trying to cook without ingredients. It'll be messy, undercooked, and possibly catch fire. So why should we care about Theon today? Well, for one thing, his book is one of the only surviving ancient sources that compiles all this Pythagorean and Platonic mathematics in one place. The Arabic translators preserved it, later medieval scholars used it, Renaissance thinkers read it and while trying to revive classical knowledge again. Think of him as the backup hard drive of the Greco-Roman maths. Without Theon, we might have only had fragments. Instead, we get the context, the commentary, the connections. And some of the maths he preserved, perfect numbers, proportions, musical ratios, still shows up today. In number theory, we still care about abundant and deficient numbers. In digital signal processing, harmonic ratios still matter. Even the monochord idea survives in how we tune instruments, though now we've traded strings for sine waves. Theon may not have discovered these things, but he ensured they weren't forgotten. He wasn't the main act, but he definitely worked the spotlight. If Theon had a hobby outside of summarising Plato, it was probably assigning personalities to numbers. His treatment of arithmetic reads less like a textbook and more like a combination dating profile and ancient zodiac. Let's take a tour through his number taxonomies. Primes and composites. In Theon's world, the primes are the aristocrats, indivisible, pure, slightly aloof, and composites more sociable but a bit needy, always breaking down into smaller parts. We have even and odd, but we also have evenly even and evenly odd. So that is, evenly even, the numbers that when divided by 2 still give you an even number, and the evenly odd are the numbers that when divided by 2 we get odd numbers, so 6 for instance. Mean, medial, and noble numbers. Ooh, they sound lovely. In Theon's context, these labels describe how numbers relate in ratios. A mean number might be the arithmetic mean between two others, whereas a medial one fits harmonically, and a noble number... Actually, if I'm honest, I'm not quite sure what he meant by a noble number, or how it really fits as the ratio between two numbers. In the modern definition of a noble number, it's any value that is an irrational number with a continued fractional form that eventually has an infinite list of ones. I'm not sure how that relates to ratios, so I'm not sure if that's what he means. Also, I don't think that they really had continued fractions back then. However, to add intrigue to this particular research rabbit hole, phi is a noble number by the modern definition, and phi was definitely a ratio that was relevant to the ancients. So, ultimately, I'm not really sure where this one goes. I think I'm just going to stop researching. This taxonomy served a deeper purpose. For Theon, they represented the numerical structure of reality. To understand the cosmos, or music, or the human soul, you had to first understand what kind of number you were dealing with. Modern mathematics might not speak in these terms anymore, but the spirit of classification is still alive. We still group numbers by properties: rational versus irrational, algebraic versus transcendental, real versus imaginary. Theon's categories were a precursor to this. If you're picturing Theon's writing as a dusty manuscript full of abstract generalities, think again. He's surprisingly practical. His arithmetic sections include numerical examples, step-by-step computations, and even approximations. What he doesn't do, however, is use any symbols. No plus, or equals, or even variables. This was still the rhetorical age of mathematics, so no algebraic notation at all, just long, long sentences. Block capitals, no spaces. Theon's work reads like a mathematical audiobook, transcribed by a monk with insomnia. Because possibly it was. That makes Theon's clarity all the more impressive. Without modern tools, he still manages to explain the Euclidean algorithm for finding the greatest common divisor, as well as the concept of proportionality, including the difference between numerical and geometric reasoning, and a method for constructing mean proportionals, which is key to Plato's cosmology. If we're honest, Theon didn't change the course of mathematical history. He didn't revolutionise geometry or derive new theorems. He didn't spark a numerical renaissance or challenge the status quo. But what he did do was arguably just as essential. He preserved, clarified, and organised. In a time when much of Greek mathematical tradition was at risk of being scattered, Theon brought it together. He respected the old masters, explained them carefully, and made them accessible. His writing became a bridge between generations, between Pythagoras and the Platonists, between philosophers and mathematicians, and eventually between the ancient and the modern worlds. He's a reminder that not every mathematical contribution has to be explosive. Some are quiet, structured, and deeply lasting. Sometimes the best way to illuminate a path is to hold the lantern steady. So what do we learn from Theon? That maths isn't just about solving problems, it's about listening. To numbers, to intervals, to cosmic rhythms, and to other people. Theon saw maths not as a cold calculation, but as a harmonic framework for understanding the universe. He reminds us that behind every theorem is a worldview, behind every proportion a principle, and behind every number a question, one that sometimes sounds like music and sometimes looks like homework. In honouring Theon, we honour the many translators of thought, the scribes, the summarisers, the patient explainers who make genius approachable, the ones who don't just push knowledge forwards, they carry it, and of course the librarians. He might not have given us all the answers, but he did give us a pretty decent study guide. Well, this has been the Mathematicians Podcast. I'm Benjamin Cornish, and if you enjoyed today's episode, and you are one of my closest and dearest friends, then pick up the phone and give me a call. It really does help support the show. And if you don't have my personal mobile number, but still want to get in touch with me, you can find me on Blue Sky at mathematicians-pod. Or just wait until next week, where, can you believe it, we are finally doing Ptolemy, where I will be tolling you all about it. Until then, goodbye. The music today is Dance Macabre Finale by Kevin MacLeod. You can find more information in the show notes.